Hello everybody, welcome back to the RostyMaths channel and welcome to this video all about distance time graphs. So in this video we're going to interpret distance time graphs. Stick with me right the way through to the end because there's some really good stuff for you to learn. Okay, so I have got a grid here that I'm going to be using to explain the different parts of a distance time graph. So without any further ado, let me just jump straight into that and get that going. So here, first thing that you're going to see on a distance time graph is you're going to have lines, a line going up like that. You will also have lines going across like that. And you will also have lines that are going down like this. So let's establish a few bits and pieces before we get going. So the first thing to establish is, usually at the very beginning of the question, they'll tell you where something starts. This is home. So you're going to start from that point. It's not always the case. Sometimes you can start further up the line or whatever the case might be, but wherever you start, your time is usually, that's your starting time. It could be 0 or it could be a specific time that you are starting from. I'm going to keep a straight line because we are looking at a constant speed. Okay, now we've learned in my last lesson, link above there, that average speed is the distance traveled divided by the time taken. So the first thing I'm going to mention is that this line here means something is moving. So if the speed varies, you'll get a curve. But in this case, this is constant speed. So I'm going to write down that this here is constant, which means that something is moving. Okay, so there's movement happening there. Now, when you get to this bit here, whatever it is, notice that the distance is not going up or down. So whatever it is, it's stopped moving. So at this point, we say that it is stationary. So that's stationary, which means it's not moving. And the reason why we say that that's stationary is because distance is not moving, but time is still going. And that's because time waits for no one. Now, when you finish being stationary, you can keep moving away from home going up, or you can move back to home. So again, I'm going to say that constant speed or something is moving here. But the difference here is that whatever is moving, it's moving back to the position of home. Now, let's go and deal with how we solve problems. So here I have got a problem facing us where the graph is already drawn and we have some questions to answer. But don't forget that this is all about interpretation. So we are interpreting the distance time graph. So let's go straight into it. Let's read the information and see what we've got. The graph shows a family's car journey. The family left home at 8 a.m. Oh, so I might need to make some changes here. So let me do that now. If the family leaves home at 8 a.m., then this means that it's 9 a.m. here, 10 o'clock, 11 o'clock, 12 o'clock there. So I'm gonna, just leave that as 12 o'clock. So I'm going to remove this hours so that it's not in my way, and I'm going to remove these timings here as well to make life a little bit simpler. So I'm going to put my 12 o'clock there. So this is time in hours, so I know what's going on. All right, so let's go back to the question. So how long did the family travel before they stopped? So let's interpret the graph. You can see them traveling here, and then they stopped for a short while, and then they went back home. So how long means time. How much time did they take traveling before they stopped? Well, they traveled here, and it looked like they stopped at 9 o'clock. So they traveled for 1 hour. So I'm going to say that this is 1 hour there. So it took 1 hour traveling. Then it says, how far means distance. How far have they traveled when they've stopped? So you can see they traveled and then they stopped there, and home was 0 and they're 50 miles away. So therefore they traveled 50 miles. How long did they stay at their destination? So it is clearly that they have stopped for a bit, and this is the bit that they stopped. How long did they stay at their destination before heading home? Well, they got there at 9 and they left at 10, so that means that they stayed for 1 hour at their destination. And what time did they start back home? Now, this is a really specific question about the time, okay? So it looks like they started back home at 10 o'clock. So that's going to be 10 a.m. Now, make sure you look at your question. If it's written in 24-hour time, then you would say the time that they headed back home, you would have said would have been 100 hours like that. But because it's written as AM and PM, 12-hour time, we're just going to say 10 a.m. You have to put that AM in. Okay, last 2 questions before we finish up this video. How long did the journey home take? How long? That's a time thing again. So they started home at 10 o'clock and they got home at 12 o'clock. So how long is that? Well, that's 2 hours. And finally, what was their average speed on the journey home? All right, so what was the average speed heading home? Now, as I've referred back to that last video, we know that average speed is distance divided by time. The distance that they traveled to get back home is 50 kilometers because they had to go all the way down. The time it took them was 2 hours, so their average speed on the way home is 25 miles. Just put mph, mile per hour, and that is the end of that. So that's basically it, guys. That's how you interpret a distance time graph. Did you get it? If you did, smash that like button. Don't forget to subscribe below and hit that notification bell so you know when the next video has landed. But for now though, until I see you on the next one, peace.